All right, next part is a little bit of solving. So we have a pattern 12, 18, 27. This is the first, second, and third number in the sequence. And then eventually this sequence is going to be greater than 1,000. And so the question is when does that happen? So really we're solving for the n value, these red numbers, and we need a first equation to work with. Now, this one here is a multiplying pattern, and to find out what it's multiplying by, if we divide these, 18 divided by 12, that'd be 1.5. It looks like it's multiplying by 1.5. Let's just confirm that. 27 divided by 18 is also 1.5. Okay, so this pattern here then multiplies by 1.5. The equation, if we substitute in our starting value 12 and our ratio 1.5, n minus 1, we're going to use this to solve. So eventually this will be equal to 1,000. And so 1,000 is substituted in for a eventual value. That's the u sub n. And we need to solve this for n. 12 times 1.5 n minus 1. Now I like to put parentheses around the ratio just so that it just looks better in my opinion. However, some people then go and distribute the 12. Do not do that. The 12 is regular. The 1.5 is repeatedly multiplied with this exponent that we're solving for. Now, obviously, you could just trial and error this. You could plug in numbers until eventually you get one greater than 1,000. And you could do this with nothing more complicated than a guess and check. However, that doesn't show a deep understanding of the solving process, and this is required for maybe more complicated ones than even this. So solving this out, we would, instead of distributing, we would divide both sides by 12 so that cancels. And I'm going to leave this as an uncalculated fraction. If I calculate that, it's going to produce a decimal I maybe want to avoid. Moving forward, though, the problem then looks like 1.5 to the n minus 1. And right here, this is, to solve this, we have to undo this base. This part of the problem is called the base, that which has the exponent. And we want it to cancel out from the side, and there's a specific way to do that using your logarithm skills. And so we're going to log both sides. However, the size logarithm, if we leave it like that, would be a base 10. And so we want to cancel out 1.5, which means that this logarithm has to have a subscript of 1.5. And if it does so, it cancels with the 1.5 that is currently in the problem, and that helps us move forward. Now, logarithm itself is a very complicated idea, and at this point in time, all you need to understand about it is that it is the opposite operation of this base. It's that the step that will cancel that out. That's as much as is necessary at this point. And there is an entire logarithm unit where we will go further into it, but just to get us rolling, that is its function in the solving process. Okay, then we're set up with this, which is great because we got n is no longer an exponent, and logarithm base 1.5 of this 1,000 over 12 is a number. That is some value that we can calculate, and to do so, we're going to go ahead and consult our calculator. Just head it up there and we'll show you how to get it. Now, under math, if you go down to option 11, which is designated with the A, mine has the log base option. Older calculators do not, and so there's a workaround that I'll show in a different video about how to do logarithm calculations if you don't have this feature on your calculator. Long story short, you essentially have to go to a different calculation or a different calculator, maybe an online option. So I selected that, it puts it in the main line, and then I'm going to change the subscript to 1.5, which is the specific size logarithm in this problem. And then in the logarithm, 1,000 divided by 12 is 10.9. So moving forward in the problem, we just calculated this value. It was 10.9, and now it's n minus 1. We have yet to add 1, which would then turn it into 11.9. And there is no 11.9 number. This is not possible, which is why the question is written as such. The first term that is greater than 1,000 would then be the 12th number. So 12 is n. And let's just go ahead and test this. If you plug it back in, we're going to test n equals 12 in the formula. 12 is also the starting number, times 1.5, and the 1.5 would then be to the n minus 1 is 11, 11th power, and let's see if it's above 1,000. So if we go in and put it in, 12 times 1.5 to the 11th, 1,037. So it is in fact above, and if we try to maybe confirm that and say, well, what if we made a misstep somewhere? Does the 10th one, the one prior is not, it's below 1,000, so the 12th one, which has exponent 11, the 12th one is the first one that is above 1,000. So there you have it. It's solving requiring logarithms.